All right, in this video we'll look at an example of how we convert from the S domain back to the time domain. We have 5 different problems that we'll solve, and to solve them we're going to use the Laplace transform table. So this is a table from your textbook. We're in the S domain. How do we get back to the time domain using this table as opposed to using the inverse Laplace transform integral? So let's look at our first problem, VA of S. That was just equal to 10. So 10, that's just a constant number. It's 10 times 1, right? So we want VA of t, that's our inverse Laplace transform of VA of S, or inverse Laplace transform of 10. Or we can pull 10 out. That's our homogeneity theorem. We know from the integral that we can pull that out. It's a constant. It's not a function of S. It's not a function of t. So we just want the inverse Laplace transform of 1. And from our table, the inverse Laplace transform of 1, that's our impulse function. So that's all we have to do for that one. That's our result. If we look at B, that was 10 over S. So that's in the frequency domain. It's a function of S now. Our inverse Laplace transform of VB of S is our inverse Laplace transform of 10 over S, or 10 times the inverse Laplace transform of 1 over S. And U of t, that transforms to our 1 over S, so we can just do our 10 times U of t. If we look at our third one, we have 10 over S squared, and writing out our problem properly, that inverse Laplace transform, this is an L in script form. We can, again, 10 over S squared, pull out the 10, 1 over S squared, that transforms directly from our table to t U of t. So we have 10 t U of t, that's our ramp function. So we want to be able to work in the S domain and easily convert back to the time domain and understand how to do that. All right, let's look at problem D. Problem D, we didn't have something nice and easy on the denominator. We had S times S plus 10. Well, if you've used your differential equations, or perhaps in Calculus 2, you learn how you do your partial fraction expansion. Partial fraction expansion, we can say that's equal to some A over S plus B over S plus 10. And then we'll look at using the method of residues to solve for A and B. But right now, we just want to show that we've now converted this to two rational functions where the denominator, the 1 over S, that was our unit step function. We've seen that. The 1 over S plus 10, we've seen that also. That's the shifting function. So our inverse Laplace transform of V of D, that's A over S, plus inverse Laplace transform of B over S plus 10. This is going to give us our unit step function, A times our unit step. This is our frequency shift function, our frequency shift function. We multiply, we get 1 over S. It's shifted, but the S is added 10, so that we multiply it by our U of t by e to the negative 10t U of t. And we're using our frequency shift property to do that. And then we can get our result. All right, well, let's look at this problem. Now we have a function 10s over s plus 10. So the s plus 10, what we just saw is, well, that gave us a e to the negative 10t U of t. But we have s in the numerator here. So this is what we call a non-rational function. We have to rationalize this function by breaking it up into two functions. So basically, we have to divide s plus 10 into 10s. So that goes in there 10 times. We multiply by 10. We end up with 10s plus 100, right? But then this is a plus 0. So we end up with, when we subtract it, we end up with negative 100 as a remainder. Our result then is 10, the remainder, minus 100 over the divisor s plus 10. So we can write this as 10 minus 100 over s plus 10, and that we can take the inverse Laplace transform of, because they're both rational functions. So if we have 10 minus 100 over s plus 10, we can do the inverse Laplace transform of 10. That's our impulse function multiplied by 10, and this is our unit step function with a frequency shift of 10. So, excuse me. So we can go through that. Our inverse Laplace transform, 10 times 1, that's 10 times our impulse function. Our 1 over s plus 10, that's our 1 over s with a frequency shift of 10. That frequency shift of 10 in time domain we multiply by e to the negative 10t. Alright, so you want to be able to practice using the Laplace transform table so we can do our inverse Laplace transforms after working in the frequency domain to get back in time domain.